You have been told the same thing so many times that you have stopped questioning it. You are tired because you are getting older. Your energy is not what it used to be, and that is just how it goes. The fatigue you feel every morning before the day has even started, the heaviness in your muscles by early afternoon, the way a full night of sleep no longer seems to restore anything. Your doctor looks at your blood work, says everything is normal, and sends you home. What most doctors are not checking, and what a significant body of research now connects directly to this exact fatigue pattern, is magnesium. Not the magnesium level on your standard blood panel, because that number is almost always normal, even when your body is profoundly deficient. Not the magnesium in your multivitamin, which almost certainly contains a form and dose that your cells cannot adequately use. The specific intracellular magnesium status that determines whether your mitochondria can produce energy, whether your muscles can relax between contractions, whether your nervous system can reach the deep sleep stages where genuine restoration occurs. That is what I am going to show you today. I am Dr. Edward. Before anything else, what you are about to hear is educational information based on published scientific research. It is not a substitute for personalized medical care. If you are on medications for kidney disease, heart disease, or take any diuretics or blood pressure drugs, please work with your doctor before adjusting your magnesium intake, as these conditions affect how your body handles this mineral. And please subscribe to this channel right now if you have not already. I publish this research every week, the kind that changes the questions you ask your doctor. It is free, takes 2 seconds, and this video is just one of many that could change how you understand your body. Subscribe and stay with me. Let me start with something that most people, including most general practitioners, do not fully appreciate about how the body stores and uses magnesium. Because this single misunderstanding is the reason magnesium deficiency goes undetected in millions of seniors every year, and it is why a normal blood test result is giving both patients and doctors false reassurance. Your body contains approximately 25 grams of magnesium. Less than 1% of that total is in your blood plasma, the fluid that a standard blood magnesium test measures. The remaining 99% is stored inside cells, primarily in muscle tissue, bone, and the mitochondria of metabolically active tissues. When your dietary magnesium intake falls, your body does not allow blood levels to drop. It pulls magnesium out of cells and bones to maintain the plasma concentration within its narrow normal range. Your blood test looks normal. Your cells are being depleted. The depletion is invisible on the standard panel until it is severe enough to overwhelm the body's compensation mechanisms, at which point you are not subclinically deficient. You are clinically deficient, and the symptoms have likely been building for years. A study published in the journal Nutrients analyzed data from the National Health and Nutrition Examination Survey and found that approximately 48% of Americans, nearly half the population, consume less than the recommended dietary allowance of magnesium. In adults over 60, this proportion is higher because absorption efficiency declines with age, because proton pump inhibitors and diuretics, two of the most commonly prescribed drug classes in seniors, directly reduce magnesium absorption or increase renal magnesium excretion, and because the foods richest in magnesium tend to be systematically underrepresented in the diets of older adults. The recommended dietary allowance for magnesium is 420 milligrams per day for men over 30 and 320 milligrams per day for women over 30. The average American adult gets approximately 250 milligrams from diet. That gap, 70 to 170 milligrams per day below what the body requires, accumulates over years into the kind of intracellular depletion that standard testing cannot see, but that every cell in the body can feel. Now let me explain what magnesium actually does, because most people have a vague sense that it is involved in muscle function and leave it there. The biology is far more fundamental than that, and understanding it explains why the fatigue, the sleep disruption, the muscle cramping, and the anxiety that so many seniors experience as separate and unrelated problems are, in many cases, expressions of a single underlying deficiency. Magnesium is a cofactor for over 300 enzymatic reactions in the human body. That number is not an abstraction. It means that 300 distinct biochemical processes require magnesium to function at all. But the most relevant to the fatigue pattern is its role in ATP synthesis. Every Every molecule of ATP, the energy currency that every cell in your body runs on, must be bound to magnesium to be biologically active. Magnesium ATP is the functional form. Without adequate magnesium, your mitochondria cannot produce or use energy efficiently, regardless of how much you sleep, how well you eat, or how carefully you manage your health. The cellular machinery that generates vitality is dependent on magnesium at its most fundamental step. This is why the fatigue of magnesium deficiency is qualitatively different from ordinary tiredness. It is not the fatigue that a good night of sleep fixes. It is a deep cellular exhaustion, the kind that is present when you wake up, that makes moderate physical effort feel disproportionately hard, and that does not respond to rest because rest cannot compensate for inadequate ATP production at the mitochondrial level. The second mechanism involves muscle function. Magnesium and calcium are physiological antagonists in muscle tissue. Calcium triggers muscle contraction. Magnesium triggers muscle relaxation. The ratio between them determines whether a muscle contracts, holds its contraction, or releases. When magnesium is depleted, calcium becomes relatively dominant. Muscles contract but do not fully release. The result is the persistent muscle tension, the nighttime leg cramps, the restless legs, and the general sense of physical tightness that is so common in older adults and so consistently attributed to aging or poor circulation. In many cases, it is neither. It is the calcium-magnesium imbalance of chronic magnesium insufficiency expressing itself in the tissues most sensitive to it. A study published in the Journal of the American Geriatric Society followed 340 adults over 60 and measured the association between dietary magnesium intake and objective measures of muscle strength and physical performance. Participants in the lowest tertile of magnesium intake had significantly lower grip strength, slower gait speed, and greater difficulty with functional tasks compared to participants in the highest tertile, independent of age, physical activity level, and other dietary factors. Magnesium was not just a correlate of muscle function, it was an independent predictor of it. The third mechanism is sleep, specifically the regulation of deep sleep. Magnesium modulates the NMDA receptor and the GABA receptor system in the brain, the same receptor systems targeted by certain sleep medications. It acts as a natural calcium channel blocker in neuronal tissue, reducing the excitability of neurons and promoting the transition from waking alertness to deep, slow-wave sleep. When magnesium is deficient, the nervous system remains in a state of relative hyperexcitability. Sleep onset is delayed. The deep sleep stages, the stages where growth hormone is released, where cellular repair occurs, where memory consolidation happens, are shortened. The person sleeps for 8 hours and wakes up feeling like they did not sleep at all because the restorative phases of sleep were compressed by a nervous system that could not fully downregulate. A randomized controlled trial published in the Journal of Research in Medical Sciences gave elderly subjects either 500 milligrams of magnesium oxide daily or a placebo for 8 weeks. The magnesium group showed significant improvements in sleep onset time, sleep efficiency, sleep duration, and early morning waking frequency compared to the placebo group. Serum melatonin levels were higher and serum cortisol levels were lower in the magnesium group, two hormonal shifts that directly support deeper sleep and reduced overnight stress activation. Now I want to tell you about something I find genuinely compelling, which is the relationship between magnesium and anxiety in older adults. The hyperexcitable nervous system I just described does not only affect sleep, it affects emotional regulation throughout the day. Magnesium deficiency is associated with elevated cortisol, the stress hormone, not because the person is under more stress, but because the nervous system's ability to modulate the stress response requires magnesium at multiple points in the HPA axis. Seniors who describe a low-grade persistent anxiety, a sense of unease that has no obvious cause and that antidepressants do not fully resolve, a heightened reactivity to minor stressors. This is a recognized neurological expression of magnesium insufficiency, and it is almost never investigated as such. Subscribe to this channel right now if these connections are landing for you. Every week, I cover the research that explains what your body is doing in language that changes what you actually do about it. Tap the subscribe button. It takes 2 seconds, and the follow-up video to this one is already coming. Let me now go deeper on the fourth consequence of magnesium deficiency that most people never connect to this mineral: cardiovascular function. Your heart is a muscle. It is the most metabolically active muscle in your body, beating approximately 100,000 times per day, and it depends on the calcium-magnesium balance more critically than any other tissue. The electrical system that coordinates each heartbeat, the sinus node, the atrioventricular node, the Purkinje fibers that carry the electrical signal through the ventricle walls, is exquisitely sensitive to magnesium status. When magnesium falls, the electrical threshold for arrhythmia decreases. The heart's electrical system becomes more prone to irregular firing. This is why magnesium is given intravenously in emergency rooms for certain arrhythmias and for preeclampsia. Its role in cardiac electrical stability is so well established that it is on the World Health Organization's list of essential medicines. The relevance for seniors is this: the palpitations, the occasional irregular heartbeats, the episodes of faster than usual heart rate that many older adults experience and attribute to anxiety or caffeine may in some cases have a metabolic explanation in magnesium insufficiency. A study published in the American Journal of Clinical Nutrition found that low dietary magnesium intake was significantly associated with elevated markers of cardiovascular inflammation and arterial stiffness in adults over 60, independent of other dietary and lifestyle factors. Arterial stiffness, the loss of elasticity in blood vessel walls, is one of the primary drivers of elevated systolic blood pressure in seniors. The connection between magnesium deficiency and blood pressure is bidirectional. Low magnesium stiffens arteries and raises pressure, and the diuretics prescribed to lower that pressure then deplete magnesium further. This cycle runs in thousands of seniors whose physicians have not identified the root cause. I also want to address cognitive function because this is the dimension of magnesium's role that I find the most important for the senior population and the least discussed in standard clinical practice. Magnesium threonate, the specific form developed at MIT, was shown in animal studies to increase synaptic density in the hippocampus, the brain region primarily responsible for memory formation and spatial navigation. Human studies using this form have shown improvements in cognitive flexibility, working memory, and executive function in adults with mild cognitive impairment. The mechanism involves magnesium's regulation of NMDA receptors at synapses. These receptors are critical for long-term potentiation, the cellular process that underlies learning and memory consolidation. When synaptic magnesium falls, NMDA receptor function is impaired. The senior moments, the word-finding difficulty, the mental fog, the sense that the brain is not operating at its normal speed, may in part reflect a synapse-level magnesium deficit rather than irreversible neurodegeneration. This does not mean magnesium cures cognitive decline. It means that optimizing intracellular magnesium status removes a correctable impediment to cognitive function that is present in a significant proportion of older adults, and that is virtually never investigated. The difference between an impediment and a disease matters enormously in terms of what can actually be done about it. Let me give you the complete picture of what to bring to your doctor. You want a red blood cell magnesium test, also written as RBC magnesium, on a lab requisition. You want to review your current medication list specifically for PPIs, thiazide or loop diuretics, and metformin, and ask directly whether any of them require magnesium monitoring. If your vitamin D levels have not been responding to supplementation, raise the magnesium vitamin D activation connection and ask whether this could explain the resistance. And if you have been experiencing the symptom cluster, fatigue that sleep does not fix, nighttime muscle cramping, sleep onset difficulty, low-grade anxiety, occasional irregular heartbeat, put all of those symptoms together in one sentence when you speak to your doctor, because individually they will each be attributed to a different cause. Together, they point toward a single mineral that a well-chosen test can identify and a well-chosen supplement can address. One final thing I want to say before the summary, because I think it addresses a frustration many seniors carry. You have likely been told at some point that your symptoms are just aging, that there is nothing specific to find and nothing specific to do. I want to be honest with you. Sometimes that is true, but it is not always true, and it is not even usually true for the pattern I described today. The fatigue, the poor sleep, the cramping, the fog, when they cluster together in a person over 60, they deserve a real investigation, not reassurance. Not another referral to a specialist who will treat the symptom in isolation. A systematic look at the most likely correctable causes. Magnesium is one of the most common, most overlooked, and most fixable of those causes. That is why I made this video. Form matters enormously. The magnesium supplement market is flooded with options, and most of them are poorly absorbed. Magnesium oxide, the form in most multivitamins and budget supplements, has a bioavailability of approximately 4%. 4%. The majority passes through the gastrointestinal tract without being absorbed, often causing loose stools in the process. The forms with the strongest evidence for intracellular uptake and clinical efficacy are magnesium glycinate, which binds magnesium to the amino acid glycine and absorbs through a different intestinal transporter with substantially higher bioavailability; magnesium malate, which is particularly effective for muscle-related symptoms and fatigue; and magnesium threonate, which has a unique ability to cross the blood-brain barrier and has shown specific benefit for cognitive function and sleep quality. Dose for therapeutic repletion typically ranges from 300 to 400 milligrams of elemental magnesium daily in divided doses. Evening dosing is particularly strategic. Taking the larger portion of your daily magnesium with your evening meal or in the hour before bed aligns the peak absorption window with the period when the nervous system most benefits from it. Dietary sources of magnesium that are realistic for seniors to consume regularly. Pumpkin seeds are the single richest source per serving, with 1 ounce providing 150 milligrams. Dark chocolate above 70% cacao provides 65 milligrams per ounce. Almonds, cashews, and Brazil nuts provide 60 to 80 milligrams per ounce. Leafy greens, particularly spinach and Swiss chard, provide 75 to 150 milligrams per cooked cup. Black beans and lentils provide 60 to 120 milligrams per cup cooked. A diet built around whole plant foods, nuts, seeds, and legumes will consistently meet magnesium requirements. A diet built around processed foods and refined grains will consistently fall short. Before I give you the testing conversation to have with your doctor, I want to address the medications most likely to be depleting your magnesium, even if your diet is adequate. Proton pump inhibitors, omeprazole, Nexium, Prilosec, used chronically reduce magnesium absorption in the small intestine. The FDA issued a warning on this interaction in 2011, but most patients on long-term PPIs are never monitored for magnesium status. Thiazide diuretics and loop diuretics increase renal magnesium excretion significantly. Patients on these drugs can be losing magnesium through the kidneys faster than any reasonable diet can replace it. Metformin, used for type 2 diabetes, is associated with reduced magnesium absorption. If you are on any of these medications and you are experiencing the fatigue, sleep disruption, muscle cramping, or anxiety pattern I described, ask your doctor for a red blood cell magnesium test, not a serum magnesium test. The red blood cell magnesium test measures intracellular magnesium status and is a significantly more sensitive indicator of true deficiency. It is not a standard panel item, and you will need to request it by name. Here is the summary of everything we covered. Magnesium deficiency affects approximately half of all Americans and is dramatically underdetected because the standard blood test measures plasma magnesium, less than 1% of the body's total, which remains normal until deficiency is severe. Intracellular depletion produces 4 interconnected consequences: impaired ATP production, causing cellular fatigue that sleep cannot fix; calcium-magnesium imbalance in muscle tissue, causing tension, cramping, and restless legs; nervous system hyperexcitability disrupting deep sleep and elevating cortisol; and cardiovascular electrical instability contributing to palpitations and arterial stiffness. The most bioavailable supplement forms are glycinate, malate, and threonate at 300 to 400 milligrams daily in divided doses with evening weighting. The dietary pattern that prevents deficiency centers on nuts, seeds, leafy greens, and legumes. The medications most likely to cause ongoing depletion are PPIs, diuretics, and metformin. The test worth requesting is red blood cell magnesium, and if your vitamin D supplementation is not raising your levels, magnesium deficiency at the activation step is a likely explanation worth investigating. If this video gave you a new framework for understanding something your body has been telling you for years, please share it. Share it with the person in your life who is exhausted all the time. time and has been told their labs are normal. Share it with the senior who is on a PPI and a diuretic and has never been told what those drugs do to their magnesium. This information is genuinely useful, and sharing it costs nothing. Subscribe to this channel if you have not already. My next video covers the dietary protocol that maximizes magnesium absorption alongside the other minerals that work in concert with it. The complete picture of what it takes to actually restore intracellular mineral status rather than just improving a number on a test. Subscribe so it comes directly to you. I am Dr. Edward. Your fatigue has a reason. Find the reason. I will see you in the next one.